Hello, welcome guys. In this particular episode, we're going to go over the solution for Leetcode problem number 1. So the problem is, given an array of integers, return the indices of two numbers that add up to a specific target, where target is a particular number, right? So for instance, there's an example here, but before we get into the example here, there's some assumptions that they also give you. The first assumption is that each input would contain exactly one solution. So we don't have to worry about there being 2 or 3 solutions in each given input array. Another assumption they also give you is that you don't use the same index twice. So what they mean by that is that say you're at index 0, you're not double counting, right? So even if the target is say 4, you don't say it's 0 and 0, meaning 2 plus 2, right? So that's the assumption that they give you. Okay, so let's look at the example here. So in this example, they give you have an array containing 4 numbers. So these would be the indices 0, 1, 2, 3. I apologize for the noise in the background. So you have 4 numbers here, 0, 1, 2, 3. These are the indices, and target is 9, right? And you want to output 0, 1 because at index 0 there's 2, and if you add index 1, in which there's a value of 7, 2 plus 7 is equal to the target, which is 9 here. So you would want to return 0, 1 as your final output answer. Okay, so let's look at how to approach this particular problem. The brute force solution, let's start with the brute force solution, which is pretty straightforward. So the brute force solution, what you typically need to do is usually brute force, what it does, it compares all the values and tries to figure out which 2 pairs add up to the particular target. So you evaluate all the given pairs in the given array, and you can do that through a nested for loop, and you can basically check whether array at I plus array at j is equal to the target. So the idea is that if you have 2 pointers here, one pointer here which is I, which starts at the first index, the second pointer which is j, which starts at the first and runs until the end of the array, you can go ahead and sort of evaluate all pairs and try to see whether they match up to the given target, right? So so let's go ahead and write the pseudocode for this. Okay guys, welcome back. So let us examine the brute force solution to the two-sum problem brute force solution. So basically, as I said earlier, in the brute force solution, what we want to do is we want to compare all the possible pairs given in the input array, and we want to compare them to the given target, and we want to return the pair that it matches the given target, right? So it is pretty straightforward. So I have one pointer which is at I, and the other point is at I plus 1. So the idea is that I runs from 0 to the length of the array, and j starts from I plus 1 and runs till the end of the array. The reason why I started j from I plus 1 is that we have the assumption that we're not supposed to use the same element twice. If the given problem statement supposedly said that, the same element could be counted twice, then we want to, do some I squared kind of algorithm where we run the same, compare each element with itself again, right? So here I have I from 0 to nums dot length, and then I have j from I plus 1 till the length of my given array, and I basically check if nums at I, which is the actual value, plus nums at j, which is the actual value of that index, is equal to target. And if so, I return the indices, because remember that the question is asking for the actual indices of the 2 numbers, not the actual numbers themselves, right? So I would return these 2 indices. Pretty straightforward. This outer loop runs from 0 till the length of the array, and the inner one runs from I plus 1 to the the length of the array. So overall, this would take big O of n squared as its time complexity, and for space complexity, we're just using I guess we're just comparing the values here, so we're not really using, you know, we're creating a list and we're returning the list with the two indices, but we're not having an extra array or whatever, right? So this would have a constant space complexity. Okay, so can we do better? And the answer is always, usually with algorithms, it's always yes, right? So how can we actually do better? Well, now the idea with doing better is we want to sort of think about this differently in a way, right? So if we start at a given index, we can essentially find out what exactly the number we're looking for if we use a target, the information provided by target. So what I mean by that is that say you have say you start at 2, right? What is the next number that you're looking for that adds up to the target? Well, you would simply, for that, to find that out, you would simply do 9 minus 2, because 7 isn't, using the target, we can figure out that if we are 2, the number that we're definitely looking for next somewhere down in the array is 7, because 9 minus 2 is 7, right? So if you have some sort of idea that, you know, we can sort of do traversal using some sort of data structure to temporarily store each element as we go by in the array, and if we subtract the target minus the actual element, and we just look for the complement of the number as we're traversing through the array, right? So by that, what I mean by that is this, right? So this algorithm, the better algorithm, I guess, we want to take some sort of information from that, right? So let's see here. So in this scenario here, you would start at 2, right? And you would put that information somewhere, right? So you would say that, okay, I'm starting at 2, right? And 2 is currently not, so in this case I'm using a hash map because you would want constant time access, right? So 2 is not in the map, so I'm going to add the value 2 with the index 0, right? And next you would move on to 7, right? And you would say, okay, is the target, so actually first you would first start at the first index. You would say, okay, is the target minus the current value, is it in the map yet, right? So initially the map is empty when you usually start at, right? So is the target minus the value here, which means it's a complement, is that in the map? And you say, okay, no, it's not in the map, so I'm gonna add it to the map. So I'm gonna add the value with the given index here, okay? So and then you go to the next value in the array, right? So you're at 7 now. Now you take target minus the value here, and you say, is that already present in my given map? That if it is present, I know that the complement is present in my given map, so I can just return that, return the two indices in that way, right? So here I'm at 7, and I subtract 9 minus 7, right? So that is 2, and 2 is definitely in my given hash map, right? So all I need to do is extract these particular indices, and I just return 0, 1, right? Namely, if I name this map nummap, right? If I call this nummap, I just return nummap at, you know, the complement, right? So target minus the current value, current value at, you know, I guess for shorthand I would say something like this, right? And then current value in this case would be nums at I, right? And then this would be the ith index itself, right? Something like this, right? The idea is to, as you're traversing through the array, use this information of target and the actual value itself. And if you store it somewhere efficiently, you can use that information. So let's take a look at how we can go ahead and code this particular example right here, right? Okay, so the idea is that we would want to have some sort of, so let me write a sort of quick Python solution here. So you have nums, right? And I'll call my map nummap, right? Which stores all the values along with its indices, right? And so as I am going through traversing through the array, I want to keep a track, right? So I start for I in range, let's see here, 0 till the length of the nums, right? I want to start from the first index and traverse it, right? I just check for whether its complement is there in my given map, right? So I say if target, right, minus the nums at I, right, is it there in the map, right? So is it in num map, right? If so, you return the particular indices, right? So I say nummap at target minus nums at I, which is the index of its complement, and since I'm at the index I, return I, right? Else I have to add it to my given hash map, right? So I say else nummap at nums I equals I. Okay, and that's pretty much it. If you were to analyze the time complexity of this given algorithm right here, also I forgot to include the target as my parameter here, as well as here. So extremely sorry about that. But if I were to analyze time complexity now, I just do one complete traversal through my given array. So that would be a time complexity of big O of n, where n is the size of my given array. And my space complexity in this case would be, let's see here, space complexity would be also big O of n, right? Because what you're doing is, as you're traversing through the array, you are you're storing all the values along with its indices in the hash map. And if you have, n entries, you would probably need to, at most store n-1 or so entries, right? So space complexity will also be big O of n, because you're using the hash map essentially to store all the values. So let's go ahead and see the submission on Leetcode. Okay, let's go ahead and take a look at this particular solution here on Leetcode. So we have this particular function that is given to us, which takes in nums, which is basically a list, along with the target, which is the actual number that we're summing. So now, as described in the algorithm, I have the num map, which is a hash map, and I basically want to iterate through the array here. And I used enumerate here because using enumerate gives you both the item as well as the index on the same iteration, and all I have to do is compute the complement, which is, basically I just take my target and I subtract the current item I'm looking at. And if it is already in the hash map on line 11, then that means that I have seen its complement so far in my given while I'm iterating through the array. So I just return the index of its complement along with the current indices, the current index value. So this would, in this case, for this example given up here, this would return 0 and 1, right? Else, that means that I haven't, found its complement yet. So I would put it in the hash map in the possibility of, seeing the complement, right? So I would just say nummap at item equals the index, to actually put the value with its index in the hash map. And actually I just hit submission right now and it got accepted. So let me just make sure, yeah, so this is accepted, and this is in Python. Obviously, just pick the language of your choice, whatever is convenient for you, and go ahead and you can code this and have fun. All right, see you in the next episode. All right, bye.